So what's pictured is a moving coil cartridge. Now this is the transducer of a dynamic mic. Can anyone name a dynamic mic? Everyone probably owns one. SM57, exactly, thank you, sir. So the Shure SM57 is one of the most popular microphones in the world. They cost about $99, and they can be used on a ton of sources, from snare drums to the presidential podium and everything in between. And the way dynamic microphones work, it's all the same. There's a very thin diaphragm attached to a coil of wire called the voice coil, and when sound comes in the front of the microphone, it pushes that diaphragm back, which pushes that voice coil back, and then stuck up inside the middle of that is a magnet. And that causes current to be induced onto the coil, and you draw that off as a voltage, and you get sound out the bottom end. I mean, this is kind of a gross simplification. But that's how dynamic microphones work. Now, the design of this really influences the sound of it in ways that it's important to know, because it helps you understand when to use these and maybe when not to use them. And again, that's the job of the audio engineer. So what are some of the sonic characteristics that follow from this particular design? Well, they handle high SPL, sound pressure level. That means you can point them at very loud sources, and they won't break up or sound distorted, okay? Why is that? Well, because it's a relatively high mass system. It takes a lot of energy to push that piece of wire. Now, this is all lightweight stuff, but at the same time, relatively speaking, how hard does a sound wave push? Okay? You can all hear me, but you're not getting blown back in your seats, right? So sound waves don't have a ton of energy in that sense. So it takes a relatively large amount of energy to move this thing, and therefore these can accept a lot of it without distortion. So you can handle high SPL sources. That makes them good for kick drums and bass drums and trumpets and things like that. The other side of that coin is they tend to capture a limited amount of high-frequency detail. Why? Well, because high-frequency sounds have even less energy than low-frequency sounds. And so those very high-frequency energy waves tend not to move the diaphragm very much, which means you tend not to be able to hear them through this kind of microphone. They don't need power. Okay? There's no circuit in here. In fact, this is the entire microphone. Sometimes you'll have a transformer, but not always. Sometimes you have just that voice coil and the magnet and the diaphragm and a couple of wires and an XLR jack. Okay, so you don't need power. And they're not sensitive to humidity. They tend to have low output, and they need significant amounts of clean gain. So again, this is something that you pay attention to in the studio. If something needs a lot of gain, then either you need a preamp that's capable of delivering a huge amount of gain without noise, or you choose a microphone that has higher output or higher sensitivity.